Okay, this is the demo for the portable fetal monitoring system. So in order to develop a portable fetal monitoring system, we need to be able to process and analysis in dance analysis in the CTG, which is called cardiotocography, where the CTG actually contains the two signal, which is the fetal heart rate as well as the uterus contraction UC. So the data, since because of this COVID-19, we don't have the hardware. So what we do is we actually can use the open source database dataset to do some testing and classification. So as for this develop of this FYP, we actually use the CTU CHB interpretum cardiotocography database from PhysioNet, and this database was actually used by a lot of research and cited by a lot of papers. So yeah, so as you can see from here, we plot the raw data. We can see that the data actually has a lot of lost data in the middles over here. So before we do any analysis and processing, we need to do some pre-processing, which over here we will be using interpolation. And this is over here is the interpolated signal over here. And once we clean up the data, we can actually estimate the baseline. As you can see from here, this lines over here indicates the baseline of the heart rate, and the baseline will actually also mention over here, which is 133 for this particular data. And after we estimated the baseline of the data, we can actually estimate the acceleration, which is shown over here. You can see that all the green dots over here actually indicates the acceleration of the heart rate in the signal. And of course, when we can detect the acceleration of the heart rate, we also can detect the deceleration of the heart rate as well, as you can see over here. So the deceleration and the acceleration are actually stated over here. We can take the high and low. Okay, so once we already have all this information, we can throw all this information into the machine learning classification model, where we have done it in the Microsoft Azure. In this case, we'll be using multi-class decision forest, and in order to train this multi-class decision forest, we actually use a database by this UCI machine learning repository, which is the cardiotocography dataset, where they already have label out all the baselines of the fetal heart rate, acceleration, and so on, and they also mention the class of the particular data, which is categorized as normal, suspect, and pathologic. So while training this model, we can see that we actually separated 70% of the data to do training, and yeah, you can see over here. And from the evaluation, we can actually see the accuracy of the model that we trained, which has the overall accuracy of 93.7%, and the metrics, the confusion metric actually shows a very rather good results of the prediction. And once we already trained this model, we can actually apply this trained model into a web service, which is over here, where we can actually input any value that we put over here, and we can test the request and see if this is the result predicted by the models. Actually, you can see that the score levels in this case is suspect. So of course, just to be sure and just to make sure the safety of the patient that use our service, we also have a system where the doctor themselves, the authorized doctor, can actually look at the raw data of the patient and actually approve or verify or indicates this is a false alarm or false AI prediction to the mothers through the mobile apps. So that's all for the demo.